Hi everybody, it's Miss Holden here, and I am doing a review for the quarterly. So you should have already completed your quarterly review sheet. If you haven't, please do that first, and then you can watch the video. You could always rewind the video. You could fast forward the video to the parts that you had question on. There's also going to be an answer sheet on the website as well. So one of the things that you also had is like a little formula sheet. So I tried to write down everything that we've done this quarter. So here's some of the stuff that we did. We talked about exponents, the rules for exponents. So all the rules are right here in this box. If you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. If you have something with parentheses, everything gets that exponent. Negative exponents, we definitely talked about this quarter. So x to the negative m equals 1 over x to the positive m. A power to a power, you're multiplying them. This one over here is important when I have a fractional exponent, so x to the p over r. So the r actually becomes the root, and that p is the exponent. So that was one that we definitely did, and these are just a variation of that up there. So use this as you do the review sheet. Your quarterly exam is going to be a very simple quarterly on Delta Math. As you already know, Delta Math will show you an example of the problem that you're doing with different numbers, so please use that if you need to. You can also use your notes. So you're going to do that on Friday and Monday. So you have through the weekend. You certainly don't have to do it on the weekend. And it's just going to count as a little quiz classwork assignment, the quarterly, unless you're missing something or have a low grade. So if you have a 0 for something, then that quarterly can be used to replace that 0 or that low grade. So it's really just to help you and to help bring up your average. Another thing we talked about in imaginary numbers. So imaginary numbers are when we have a negative under the radical sign. So there'll be some review questions on that as well. Remember, the square root of -1 equals I, and I squared is -1. Okay, we have this I clock. Basically, anything to the fourth power is equal to 1. So if I have I to the fourth, that's 1. I to the eighth, since it's a multiple of 4, it's divisible by 4, that also equals 1. If I had something like I to the ninth, then I divide by 8, or I subtract 8, and I have 1 left over. So the I to the eighth is equal to the 1. The 1 left over is going to be equal to I. But you can also always use your calculator for all of that as well. Quadratic formula is listed here. That's on your reference sheet, so you never have to memorize that. The discriminant can tell us a little bit about the roots. So your discriminant is b squared minus 4ac. And then if your discriminant is greater than 0 and a perfect square, or less than 0 or equal to 0, it tells you about the roots. So we have that chart right there. Just different parts of the quadratic. Some of this you did in algebra last year, but this year we introduced something called the focus and the directrix. So the focus, this is my vertex form of a parabola. And the vertex is HK. So the numbers right here, HK, that's the vertex of the parabola. This is vertex form. So remember that your turning point is halfway between your focus and your directrix. So here's my focus, here's my directrix, and the turning point is smack in the middle between them. All right. This is just dividing, so that's something that we did recently back in Unit 10. All right, so this is a little example of how to divide right there. When you're doing it on Delta Math, they'll also show you an example. This is a synthetic division, which you don't have to do. Some of you did like the synthetic, so whichever way, fine. The remainder theorem, basically, if you are dividing by x minus a, if you find f of a and plug it in, that gives you your remainder. That's the same thing as doing all this if you just have to find the remainder. Okay, and the factor theorem is right here. Again, it's a factor. X minus a is a factor if you find f of a and it equals 0. All right, and then our probability formulas. There was not any, I didn't put any probability practice on the review sheet because we just finished that, but here are your formulas just to have them as reference. And there's probably, I think, just 2 questions on probability on your Delta Math that you're going to do. All right, so here we go. Just a quick little explanation of these answers. So this is a third quarter review sheet that you should have already done. We did some factoring, so just basic factoring right here in number 1A. You're always looking to find the greatest common factor. The G got cut off right here. So the greatest common factor, what number and what letter. So 5 is the biggest number that 10 and 35 have, and X is the biggest X they have in common. So I pull out a 5X. What's left? If I divide out 5X from 10X squared, I'm left with 2X. If I divide out 5X from negative 35X, I'm left with negative 7. You should be able to multiply this and get back the original, so that's a way to check that. 1B is the difference of 2 perfect squares. So 25 minus 4y squared, the factors are 5 minus 2y and 5 plus 2y. C is just a trinomial that I'm factoring. So 5x times x is 5x squared. And then you do have to play around. You're saying what numbers multiply to 6 and combine together to give me the 13. There's a couple different combinations that give me 6, like 1 and 6 give me 6, or 2 and 3 give me 6. It turns out to be 2 and 3. It's very important where you put the 2 and the 3, though, because whatever number you put here is actually multiplied by 5. So 5x times 3 is 15x, and negative 2 times x is negative 2x, and that's how it combines together to give me this 13x in the middle. D is another trinomial, but this time I can factor out a greatest common factor of 4. So when I factor out a 4, I'm left with 2. I'm just dividing out that 4. I'm left with 2x squared minus x minus 6. Now I have this nice trinomial that I'm going to factor in here. So my factors, I put my 2 sets of parentheses. 2x times x is 2x squared. Again, I have to figure out my factors of 6. Are they 1 and 6? Are they 2 and 3? And it's just a matter of testing it out. They are 2 and 3. The 3 needs to go here because 3 times x is 3x. And the negative 2 needs to go here because negative 2 times 2 is negative 4x. So this actually gives me a negative 4x and a positive 3x. And that combines together to give me my middle term of negative x. Factoring by grouping. So I have 4 terms right here. The first 2 terms I'm going to group together, and I'm going to factor out the greatest common factor. So the greatest common factor is x squared. When I factor out an x squared, I'm left with 3x plus 4. And then I'm going to do the same thing right here. I'm going to group these together, and I'm going to pull out the greatest common factor is negative 25x. And what's left is 3x plus 4. It's important to factor out a negative 25 because I want to make sure that this factor, 3x plus 4, matches this factor right here, 3x plus 4. So I did have to think about the signs there. And then all I do is the factor that I pulled out, those get combined together. X squared minus 25 is a factor. And then the 3x plus 4 that they had in common was a factor. The x squared minus 25, you do have to recognize is the difference of 2 perfect squares. So that just factors to x minus 5 and x plus 5. So that's my answer right there. We also did factoring when I was solving. So I'm going to factor and set each factor equal to 0 and solve. So I have 2x squared minus 13x minus 24. My factors are 2x and x. And then the factors that multiply to 24, you have a couple of possibilities like 1 and 24, 2 and 12, 4 and 6. This one, 3 and 8 are the factors. Negative 8 times 2 is negative 16x, and 3 times x is 3x. That's positive 3x. So those together will give me a negative 13x. So I'm playing around and I'm just testing out where those numbers can be. And then I set each factor equal to 0. So 2x plus 3 equals 0, x minus 8 equals 0. And I solve, and my answers are x equals 8 and x equals negative 3 halves. Here's one a quadratic that I want to put in vertex form so I can identify its turning point. So basically, I need to have this x squared have a coefficient of, I wrote 0, but I really wanted to have a coefficient of 1. So I factor out the 4, but just from the first two terms because this 15 is not divisible by 4. So I sort of shove this 15 to the side a little bit. I factor out a 4, and I'm left just from the first two terms, and I'm left with x squared plus 6x. I then have to complete the square. So x squared plus 6x, half of 6 is 3, and 3 squared is 9. So I'm adding on 9. But I'm not technically adding on 9 because this whole thing is multiplied by 4, so I'm really adding on 4 times 9. To keep this balanced, all right, I want to subtract 4 times 9 because I can't just add on 4 times 9 without keeping it balanced. So I can either add on 4 times 9 to the other side, but that eventually is going to come over here anyway. So all I did was subtract 4 times 9. Now, negative 4 times 9 is negative 36. This nice trinomial here is a difference of two perfect, well, it's not a difference, it's perfect square. It's x plus 3 squared. The 15 minus 36 is negative 21. This is now in vertex form, and my turning point is negative 3, negative 21. So this number here, right here, you do have to change the sign on. The negative 21, of course, you don't have to do that. All right. Next page. Number 5 is another problem where I have focus and directrix. So remember the turning point has to be halfway between the focus and the directrix. So this right here is my directrix, y equals 7. My focus right here is 3, 4. So my turning point has to be smack in the middle between that. So I just sort of draw this line, and this is 3, 4, and this is 3, 7. So right, there's 3 this way, 3 this way. My turning point is 3, 4. And you can just do that visually by looking at the graph. To sketch it, my parabola has to go this way because the parabola is any single point on the parabola is midway between, equidistant between this focus and the directrix. So it probably should have been a little bit wider, but I didn't, this is just a sketch. They do want to know if that leading coefficient is going to be positive or negative, and it would have to be negative because look at it, it's facing downwards. The graph is pointing down. Okay. Number 6, you are solving the square root equation. To do that, you have to get this radical all by itself. So I subtract 19 from the right and I get 30. And then I still have to get it by itself by getting rid of this 5. So I divide by 5. 30 divided by 5 is 6. Once I have this radical by itself, to get rid of the radical, I'm going to square it. Whatever I do on the left, I have to do on the right. The square root squared just gives me x minus 4. And then on the right, 6 squared is 36. And to solve for x, I would be adding 4. And that's how I get 40 as my answer. We're now going to work with some exponent rules. So in 7a, I'm going to multiply on top. When I multiply, I add the exponents. So that's x to the 8th divided by x to the 4th. So now I'm dividing and I subtract the exponents and I have x to the 4th. So that's just a basic one. This came out a little blurry. This is a 3 right there. So everything basically is to the third power. The negative 2 is to the third power, and the x to the 5th is to the third power. And the y squared on the bottom is even to the third power. So negative 2 to the third power is negative 8. 5, the power to a power, you're multiplying these, and it's x to the 15th. And on the bottom, a power to a power, you're multiplying, so that's y to the 6th. Now I have some radicals. I also have some exponents in there as well. So the 75 breaks down to 25 and 3. I'm breaking it down to a perfect square. Radical 25 is 5. The radical 3 stays as a radical though. X to the 9th. So basically I break it down to the highest even number I can, which is x to the 8th. And the square root of x to the 8th is x to the 4th. And then I had that x to the 8th. It was originally x to the 9th, so I break it down to x to the 8th and x to the 1. That radical x is going to stay a radical forever. So anything that's staying a radical is under the radical sign, and anything that was a perfect square, like the 25 is 5, and the x to the 8th is x to the 4th. Same thing I can do with a cube. It does get a little bit trickier though. I have to think, when I'm breaking this down. The cubed root of 8 is a perfect square, and the cubed root of 2. So basically 16 breaks down to 8 and 2. The cubed root of 8 equals 2. The cubed root of 2, however, is going to stay the cubed root of 2. And then when I'm doing it with the exponents this time, I need to break it down to the biggest number that's divisible by 3. So the 14 breaks down to 12 and 2. The cubed root of 12 is y to the 4th. And then the y squared stays as a cubed root. When I'm simplifying and I have fractions, and I'm going to have negative signs over here, but just it's really similar to the question that I had up here, just a little bit more complicated because I have some fractions going on. But when I'm multiplying, as long as the bases are the same, I'm going to add these exponents. So I'm really adding 2 plus 1/3. You can do that in your calculator. It would give you a decimal. And then you just hit the math key and change it back to a fraction. Or this 2, you can just leave that as, let's see, it would be 6 over 3. So x to the 6 over 3 is really x to the 2. And then I'm just adding 6 over 3 plus 1 over 3. And that's how I can also get the 7 over 3. Now, once I have x to the 7 over 3 and x to the 5 over 6, I'm subtracting. You can't subtract unless your denominators are the same. If you want to throw this in your calculator, you can certainly throw it in your calculator. And again, it's going to give you a decimal, so you'd have to change that decimal back to a fraction, which is 3/2. And then remember, this denominator is the root, and the numerator is the exponent. And then I do simplify this. It looks like this got cut off down here. So I simplify it to x squared and x. And the square root of x squared is just x. And this will stay radical x. So my answer right here is x radical x. X radical x. Okay. And next page. Number 10, we're using the quadratic formula. So here's my quadratic formula. I need to know a, b, and c. A is the number next to the x squared. B is 3, it's the number next to the x. And c is the number by itself. So it's negative b, negative 3, plus or minus the square root, b squared, 3 squared, minus 4 times a, which is 2, times negative 20. All over 2 times a. And then remember, a is 2. So 3 squared is 9, negative 4 times 2 times negative 20 is positive 160. 2 times 2 on the bottom is 4. 9 plus 160 is the square root of 169. This one actually is a perfect square, so your answer is going to be negative 3 plus 13 over 4 and negative 3 minus 13 over 4. You have two answers. This simplifies to 10 over 4, which is just 5/2. And this one, negative 3 minus 13, is negative 16 over 4, which simplifies to negative 4. On 11, I'm going to solve this. So I subtract 100 and bring it over to the right. I want to get this x squared by itself, so I divide both sides by 2, and I got negative 50. The way to solve this is to take the square root. So the square root of x squared is x. The square root of negative 50 is plus or minus the square root of negative 50. And remember, when I have a negative under a radical, that's where my I comes in. So I break this down to square root of negative 25, because the 25 is a perfect square. So that's going to become 5i. It comes out of the radical. I can simplify that. And the radical 2 stays radical 2. So that's my answer. We're going to work with some more with i's in 12. So 12a, I'm just adding these. So I add the numbers, negative 8 plus 4 is negative 4, and I add the i's. 6i plus negative 3i is 3i. Done. B, I'm multiplying, so you do have to FOIL. 5 times negative 3 is negative 15. 5 times negative 7i is negative 35i. 4i times negative 3 is negative 12i. 4i times negative 7i is negative 28i squared. Now, if you remember, I squared is actually equal to negative 1. So this is negative 28 times negative 1, which is positive 28. The negative 35i and the negative 12i, I combine together to give me negative 47i. And now that this is just positive 28, I can combine it with my negative 15, and I get 13 minus 47. And I'm always putting this in a plus bi form. 13 is another quadratic formula. So negative b plus or minus b squared minus 4ac over 2a. A is 1, b is 14, c is 58, sorry. I just got confused again for a second. I have to bring this over, bring the 4x over, and that's how I get 14x. And I have to add 20, that's how I get the 58. Because you want this to be a trinomial before you identify what a, b, and c are. So I'm just plugging this in. Negative 14 plus or minus the square root of 14 squared minus 4 times 1 times 58. I simplify this, what's under this radical in my calculator, and it gives me negative 36. So I really have, then the square root of negative 36 is 6i. So I have negative 14 plus or minus 6i over 2. Since these are all even numbers, I can simplify. Negative 14 divided by 2 is negative 7, and 6 divided by 2 is 3i. So my answer is negative 7 plus or minus 3i. 14, I'm just going to find the discriminant. The discriminant is b squared minus 4ac. So 8 squared minus 4 times 1 times negative 3. 8 squared is 64. Negative 4 times 1 is negative 4 times negative 3 is positive 12. So my discriminant is 76. I can then look at my table that I had over here. So when my discriminant is negative 7, is positive, negative, positive, my discriminant is greater than 0. If it's a perfect square, you're going to have two real rational unequal roots. If it's greater than 0, but it's not a perfect square, and 76 is not a perfect square, you have two real irrational and unequal roots. Okay, so I have two roots, they're unequal and they're irrational. All right, next page, number 15. So I basically did a little summary right here when you're looking at a graph. If they're odd, they go in different directions, the endpoints. So if it's odd and positive, this one goes down on the left and this one goes up on the right. If it's odd and negative, it goes up on the left and down on the right. If it's even, then the roots are going to go in the same direction. So if it's even and positive, they're both going up. So if my exponent is even and the coefficient is positive, they're both going up. If my exponent is even, but my coefficient is negative, they're both going down. So this one right here, they want to know whether b is, which is the exponent, is odd or even. Since they're going in different directions, that exponent has to be odd. The endpoints, and that's the answer to that, and here's the explanation. The endpoints are going in opposite direction. Here's the A part of it. Is A, the coefficient in front, positive or negative? It's negative because I'm starting off on the left going up and I'm going down on the right. So it's this example right here. 16, I have a cubic. The x-intercepts are negative 2, 3, and 5. So my factors are x plus 2, x minus 3, and x minus 5. I want to find the leading coefficient of that x to the third term. So basically, they're asking me to find my a. So I set this up, y equals a, and I have my factors, x plus 2, x minus 3, x minus 5. Remember, you're doing the opposite signs there. And then I'm going to plug in 7 for x and 288 for y. And I'm going to solve for a because they want me to find that coefficient. So again, 288 goes in for y. 7 goes in for every x. So 7 plus 2, 7 minus 3, 7 minus 5. 7 plus 2 is 9. 7 minus 3 is 4. 7 minus 5 is 2. 4 times 2 is 8. Times 9 is 72. So this is really 272a, so a is 4. And that's technically my answer, because they just wanted the coefficient as this question. If you had to write the equation, then you would write the equation now that you know that a is 4, and you write your equation y equals 4, and you write all your factors down. Done. All right, so I have this rational function in number 17, y equals 2x over x minus 5. I want to know, when is this function undefined? You cannot have 0 in the denominator, so it's undefined when the denominator equals 0. So I take my denominator, x minus 5, I set it equal to 0. So when x is 5, that function is undefined. To find the equation of the inverse, I switch the x and the y and I solve for y. So I'm going to put an x in for the y, and the x's I'm going to put in a y. So x equals 2y over y minus 5. I put a 1 under here, and I cross multiply. 1 times 2y is just 2y. That's easy. X times y is xy. X times negative 5 is negative 5x. Now this looks like a mess. You want to get anything that has a y on one side and anything that doesn't have a y on the other side. Because anything with a y you want on one side so you can factor out that y, because we have to solve for y and get y by itself. So I'm going to get all the y's on one side and factor out the y. So this xy, I'm going to bring it over to the left by subtracting it. So I have 2y minus xy equals negative 5x. I now factor out a y because both these terms have a y. So I factor out a y and I'm left with 2 minus x. To get y by itself, I divide by 2 minus x. So my answer is y equals negative 5x over 2 minus x. All right, this is also another answer if the signs were different. It could also y equals 5x over x minus 2, depending on how you were cross multiplying and solving and what you brought over to which side. Okay, number 18, I want to simplify that, so I factor the top, greatest common factor, I pull out a 4 and I'm left with x minus 3. The bottom is a trinomial, I factor it to x plus 3, x minus 3. Anything that's in common I can cancel out, and I'm left with 4 over x plus 8. So I've simplified that. Number 19, I am dividing. Remember, when you're dividing, you're going to change to multiplication. So I changed this division to multiplication, and I flip this fraction right here. So that's why the x cubed goes on top, and the 2x squared plus 10x goes on the bottom. As I was flipping it, I factored it, though. So I factored out a 2x, and you're left with x plus 5. X squared minus 25 is a difference of two perfect squares, so I factor it x minus 5, x plus 5. The trinomial factors to x minus 5, x plus 2. Anything in common I cancel out. So the x plus 5 cancels with the x plus 5. The x minus 5 cancels with the x minus 5. I wrote what was left because I didn't notice at first that I had x's in common. So x cubed was on top. And then on the bottom, I have 2x times x plus 2. Well, this x cancels with one of the x's on top. So that's why I was left with x squared, because I cancel out this x. And on the bottom, I'm left with 2x plus 2. All right, we're up to this next page, number 20. I am adding. So when you're adding fractions, you cannot add unless your denominators are the same. So I take this denominator on the second fraction and I factor it, because I sort of need to find a common denominator, and it's really hard to see what the common denominator is unless this is factored. So I take this, it's x plus 5. Now I can see, well, this is x plus 5, this is x times x plus 5. It's super close. My common denominator is x plus 5. This already has the denominator, so I'm not going to do anything to this numerator. This was close. My denominator is x plus 5. So since I'm adding on an x, I have to add on the x on top. So on the top, I basically am multiplying the top and the bottom by x, so I have that common denominator of x plus 5. Now that my denominators are the same, I add the numerators, so 2x plus 10. And my denominators on the bottom, I just keep that denominator. This 2x plus 10 on top can be factored to 2 parentheses x plus 5. And then the x plus 5 on top and bottom cancel, and I'm left with 2 over x. On 21, I'm simplifying this complex fraction. So I have like these different layers of fractions. The easiest way to do it is to multiply everything by the least common denominator to get rid of those extra fractions that I have. My least common denominator, I have 5x squared, I have 20, I have 4x, and I have 2x squared. So the common number that everything goes into is 20, and the common x, the highest power, the highest exponent is x squared. So my least common denominator is 20x squared. You want the least common denominator so all of those fractions will cancel. So everything gets multiplied. See how I write 20x squared next to every single fraction? I do that because I'm not going to multiply it. I'm going to cancel out. 5x squared goes into 20x squared 4 times, and I'm left with 4 times 1 is 4. 20 cancels with the 20, and I'm left with negative 1 times x squared is negative x squared. The 4x cancels with the 20x squared, and I'm left with 5x. 5x times 1 is 5x. The 2x squared cancels with the 20x squared, and I'm left with 10, and negative 1 times 10 is negative 10. This is much easier now. I've cleared all those layers of fractions. This is a difference of two perfect squares. It's 2 minus x and 2 plus x. And then greatest common factor is 5x minus 2. Now these are really the same, except my signs are off. This is 2 minus x, this is x minus 2. I can cancel this x minus 2 with the 2 minus x, but the signs were different, so I am left with a negative 1. So I'm left with negative and then 2 plus x over 5. 22 is a long division problem. So x plus 5 goes into 4x squared plus 14x minus 2. So x goes into 4x squared 4x times. 4x times x is 4x squared. 4x times 5 is 20x. I subtract this and the 4x squareds cancel. 14x minus 20x is negative 6x. I bring down that negative 2. And now I say x goes into negative 6x, negative 6 times. X times negative 6 is negative 6x. 5 times negative 6 is negative 30. I subtract this and the negative 6x cancels. Negative 2 minus negative 30 is 28. This is my remainder. So my answer is 4x minus 6 plus the remainder is 28 all over that denominator, x plus 5. Is the binomial x minus 6 a factor? So basically you test out x equals 6. So I'm doing the opposite sign here. I'm going to find f of 6. 6 to the third power minus 9 times 6 squared plus 8 times 6 plus 60. If you do that in your calculator, you get 0. So yes, it's a factor because x equals 6 is a 0 of the polynomial. The remainder is 0. If I'm solving something that has fractions in it, I multiply everything by the least common denominator to clear those fractions. So looking at my denominators of 6, x, 2, and x, my least common denominator is 12x. I'm sorry, I can just use 6x. I don't have to multiply those. So 6x is a common denominator. Everything, look how I wrote 6x next to every single fraction. The 6's cancel, and I'm left with 11 times x is 11x. X cancels with the x, and I'm left with 6 times 1 is 6. The 2 goes into 6x 3x times. 1 times 3x is 3x. The x cancels with the x, and 3 times 6 is negative 18. Now it's just a regular fraction to solve. I subtract 3x, and I get 8x. And I subtract 6, and I get negative 24. And I divide by 8, and x is negative 3. Okay, so remember your quarterly exam is just a quiz, and you're going to do it on Delta Math, and that will be on Friday and Monday. So you have 4 days to do that, and it's going to be used just as a quiz if have taken all your tests and everything, and you don't have any low grades. If you have any low grades, or if you have any missing grades, missing tests, then it can be used to count to replace those zeros that you have. Alrighty.